Welcome back to the video lecture series of Grade 10 Chemistry. So we continue with the discussion of previous year questions. So far we discussed the year 2024 set 1 question paper section A and B. Uh, Now I'm going to discuss the section C question part. Section C is a 3-mark question. So I selected the chemistry part from this question. Each question carries 3 marks. Okay, now study the experimental setup shown in the diagram and write chemical equation for the reaction involved. Name and define the type of reaction and uh, list 2 other metals which can be used in place of iron to show the same type of reaction with the copper sulfate solution. So there are three questions asked in this question. Accordingly, you will get 3 marks. So each question carries 1 mark. So the first question, study the experimental setup shown in the diagram. So look at this question now. The experimental setup is actually uh, there's a test tube and thread and then copper sulfate solution is kept in the test tube and iron nail is placed. It is not placed, it is hanged. Okay, using a thread. That's iron nail here and a copper sulfate solution. Now, so that is the experimental setup. Now you should write the name and define the type of reaction. So Fe, iron reacts with the copper sulfate solution, CuSO4. So what is the type of reaction? This is a simple displacement reaction. Okay, so that is the answer. Now, uh, let me make it short, small. Okay. Now, what's the type of the reaction? The type of the reaction is simple displacement reaction. And if you know, you can write the equation also. Fe plus CuSO4 will give you FeSO4 and CuS. So this is the reaction. So I'll make it short for you. Fe plus CuSO4 will give you FeSO4 plus C. So the reason you already know. Fe is more reactive than copper metal. So Fe can displace copper from copper sulfate. So the product will be FeSO4 and copper will be precipitated out. CuSO4 is blue in color and Fe color you already know. After the reaction the color will change to green. Okay, it's a displacement reaction. A reaction in which a more reactive metal displaces a less reactive metal from the salt solution. Okay, and then asking one more question. Uh, List 2 other metals which can be used in place of iron. List 2 other metals which can be used in place of iron to show the same type of reaction with the copper sulfate. So you need to write 2 other metals where we can substitute with iron, the copper sulfate solution. Okay. So you can write any metal which is more reactive than copper. So far it is given a single you can write, single can displace copper from copper sulfate, aluminum you can write, calcium you can write, and even magnesium also. So these are the 4 metals. Any 2 metals only they asked. We gave 4 metals. All these metals can displace copper sulfate, copper from copper sulfate solution. Okay. So this is a 3-mark question. So 1 mark for this, 1 mark for this, and 1 mark for this. This is how the answer key. Now, next question. So different question. Name the ore of mercury. Name the ore of mercury. Hmm, and state the form. So ore of mercury is, as you know, it is cinnabar. Ore of mercury is cinnabar. Okay. And the formula is HGS. Mercuric sulfide it is. So state the form. It's a sulfide ore. Mercury is a sulfide ore. I mean, cinnabar is a sulfide ore. Then write the chemical reaction Since that's the second question, write the chemical equations along with the condition required for the reactions involved in the extraction of mercury from the ore. So basically we are supposed to write the extraction of mercury. Okay. So extraction of mercury, we have two steps. First step, it's an sulfide ore. Sulfide ore, we should convert it into oxide form, HgO. Okay, this is the first step. So mercuric sulfide you should heat in presence of oxygen. So it is converted to mercuric oxide. Okay. So sulfur will combine with oxygen to give sulfur dioxide. Once you get mercuric sulfide, you should heat in a sloping surface. Keep mercuric oxide here and heat in a sloping surface so that mercury will be flowing down. You get mercury. Okay, that is second reaction. Mercuric oxide on strong heating, mercury will be giving out. So oxygen is gas, it can release easily. So this is the step for extraction of mercury. Okay. So this for 1 mark, these two will have 2 marks. Now next question. So section D question. Section D 5 mark question. It carries 5 mark. An acid X present in tamarind when mixed with Y produces mixture Z. Z on addition to a dough U when heated makes a cakes soft and spongy. Y is prepared from common salt and helps in faster cooking. So write the common names of X, Y and Z and write the chemical formula of Y also. How is Y prepared and how does it help in making cakes soft and spongy? Illustrate the reaction with the suitable chemical reaction. Write the name and chemical formula of a mild base other than Y used as an acid. You should write the common name of XYZ and how is Y prepared and write the chemical reaction and then write the chemical formula of a base other than Y. Okay, I think you understood the question. Now we look into the answer now. An acid X present in tamarind. Okay, so here the acid is tartaric acid because tamarind contains tartaric acid. Okay, so the acid is tartaric acid and then so X is tartaric acid and Y is baking soda. Why is baking soda? So that we get baking powder. So they are asking the preparation of baking powder. So baking powder is prepared by mixing tartaric acid with the baking soda. Okay. And baking soda formula is NaHCO3. So X is tartaric acid, Y is baking soda, Z is baking powder. The chemical formula of Y is NaHCO3. So this is Y. Now, how is Y prepared from Y? How is Y prepared? And how does it help in making cakes soft and spongy? So you should write the preparation of baking soda. Baking soda is prepared by taking ammonium chloride. NaCl, sodium chloride solution. So NaCl plus H2O, and you should pass carbon dioxide and ammonia gas. Okay. So the product will be ammonium chloride and baking soda, NaHCO3. Now, for making cakes soft and spongy, ammonium sodium hydrogen carbonate or baking soda, okay, it reacts with H plus and form carbon dioxide gas will be liberated. And this liberated carbon dioxide during heating makes the cake soft and spongy. So this is the reaction behind the uh, making cakes soft and spongy. So you should write NaHCO3 plus H plus so that carbon dioxide gas will be liberated. And the carbon dioxide makes the cake soft and spongy. Now we should write. So sodium carbonate, sodium bicarbonate, usually it's a baking soda for the preparation of cakes. And another uses it's an antacid. Okay. So other than this antacid use, we can use magnesium hydroxide also. It's another antacid used for the same reason. So sodium bicarbonate as well as magnesium hydroxide also can be used as an antacid. Okay, this is a very important portion in chemistry. Sodium bicarbonate preparation and uses and cake, how carbon dioxide helps in making cakes soft and spongy, this reaction, and what is the use of antacid, and then which antacid other than sodium bicarbonate we can use. All these questions are repeatedly asked by the NCRT. The question paper law many times they are asked. So this is a very important portion. You should study very hard. Okay. Now we'll go to the next question. Next question is section E question. It's kind of case-based question having 3 marks each. I mean 4 mark. Okay. And there is 3 questions. First two will have one mark, and the last one will have 2 marks. And related questions they will ask. So here it's given a small paragraph. Carbon is a versatile element that forms on the basis of all living organisms. And many of the things we use, a large variety of compound is formed because of its tetravalency. Compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, and many other elements. So there are 2, 3 questions given. First one, what are hydrocarbons? Hydrocarbons are compounds formed by carbon and hydrogen only. Okay, it is given in the question itself, hydrocarbons. Okay, to contain hydrogen and carbon. Now second question, list two properties by virtue of which carbon can form large number of compounds. Okay, so that is the two properties are tetravalency and catenation. Tetravalency and catenation. Okay, second question answer is tetravalency. So first answer, second answer, tetravalency and catenation. Now, third question, write the formula of the functional group present in aldehyde and ketones. So aldehydes, so functional group children, most of the children will have some kind of doubts. Aldehydes, it's actually CHO group. So for detailed structure, the CH H has a single bond and oxygen will have a double bond. This is the detailed structure of aldehyde. And for ketones CO. Okay, and there are two valency should be satisfied, so you should put two bonding. And the detailed structure will be C double bond O and a single bond. This is C double bond O. Simply we say CO. That is for ketones. Now, there is one more question. Write the chemical equation for the reaction between ethanoic acid and ethanol in presence of a catalyst. Ethanoic acid and ethanol actually, there's a ester formation test. Ester formation, okay. So ethanoic acid formula is CH3 COOH. CH3 COOH. Then ethanol is C2H5OH. And you get ester CH3COO C2H5. I'll write one more time. Ethanoic acid is CH3COOH. Okay, ethanoic acid or acetic acid. It is reacting with the ethanol C2H5OH, or you can write CH3CH2OH. Both are correct. C2H5OH, alcohol, and it forms ester. So from this, one molecule of water will be eliminating. So this H and OH you can eliminate as water. The rest you need to write together. CH3 COO and then combine with the C2H5. So you'll get CH3 COO C2H5 plus H2O. This is ester. This reaction is esterification reaction. Acid reacts with an alcohol, you get an ester. Now, the last question, that is an or question. What are structural isomers? Write the structures of two isomers of butane, C4H10. Yes, we look into that answer first now. Structural isomers of butane. Butane formula is C4H10. It is an alkane. So alkane formula CnH2n plus 2. So if n is equal to 4, you get C4H2 into 4. 8. 8 plus 2, 10. So C4H10. Okay. This is butane. Now, structural isomers means they have same molecular formula. They have identical molecular formula, but they have different structures. Okay. That is structural isomers. They have same molecular formula, but different structures. So there are 4 carbon in butane. You should write 4 carbon straight in a straight chain manner, and then you add hydrogen atoms. Okay. So you will get, this is the first isomer of butane. We say normal butane or N-butane. CH3, CH2, CH2, CH3. So this is the first isomer. We can write it as normal butane or N-butane. Now, one more structural isomer you can write by writing. Out of the 4 carbon, we write 3 carbon in a straight chain manner. 4th carbon, we can do it in the, write it in the second carbon. Okay. So we are reducing the chain length. Before it was 4, now it is reduced to 3. Fourth one is putting in the second carbon. Now you put a hydrogen. Okay. This is called isobutane. Iso, isobutane. IUPAC name is different, but now it is not needed. CH3, CH, CH3, CH3. So these are the 2 isomers of butane, normal butane and isobutane. So as of now, we completed the 2024 set 1 chemistry questions in the science question paper. Thank you, children.